Now let's see today's lab. Binary expression tree. We already know binary expression tree like a general. We just need to know how to make it. So what I'm going to explain is just like two things. How to build a binary tree. That's the first thing, a binary expression tree. Let me copy the second one. So times 20.0, then plus 3.0, then -4. How can I build this tree when I have 23, -4, plus and times? I'm going to use stack. If it's not operator, push into the stack. Not operator, push into the stack. Not operator, push into the stack. If it's operator, pop from the stack. First popped will be right child. Then pop from the stack. Second child will be left. Second pop will be left child. So when I push into the stack, if I already made tree node, that is better. Then, am I done? No, actually not. After you make it, you are going to push into the stack. So now I'm going to push the whole tree. To push it into the stack, you can just push this tree plus a tree node reference into the stack. Then the whole family will follow. So now into the stack, you have two things. One is node 20, which was pushed at the first. Then second item in the stack is plus operators subtree. Now I'm going to reach to the last one times. If it's operator, make a tree node, then pop from the stack. So add it as right child and pop from the stack, add it to the left child. That's it? No, you need to push this one into the stack. So now my stack has only one node, but this node has a whole family. Then end of the string, then you are going to pop from the stack, that is the build tree. Now I'm going to explain about the evaluate node. Evaluate node can use also, evaluate node, I can just use the recursive method. First, I start from the root. Depends on what I have. If I have times, what I'm going to do is I'm going to multiply from evaluated node left child times evaluated node right child. Now let's see. Next time, evaluate node left. What will happen to here? This one is just 20. So if it's not operator, you just return the current one as a double type. Double that, parse double, then my value. So from the evaluate node left, what will be returned? 20 will be returned as a number, double type number. So 20.0. How about evaluate node right? Evaluate node not right will do, it's operator. So it's going to call evaluate node left, that is 3. Then evaluate node, actually node 3. Evaluate node -4, the right child. Then evaluate node 3 will return value 3. Then evaluate node -4 will return, right child will return -4. Then it's going to add, then return the final value to the black evaluate node right. So it's gonna be like a -1. So final result will be -20.0 will be returned. If you build the tree correctly, infix prefix is not hard, so you can just do it. And evaluate node is just a recursive method by calling evaluate left, evaluate right. And there's a base case. If it's not operator, you are gonna just return the current number. How about if it's null? But if root is null, you are going to return 0.